Hey guys, today we're going to talk about factoring polynomials using greatest common factors. Now, if you're unfamiliar with all sorts of different methods of factoring, check out my video that talks about when to use what factoring method. But a pretty common one, the most common one I may say, is through greatest common factors. Now, greatest common factor might not be a term you've heard since you were in middle school. Let's think back to what it means. It means a number, or in this case a variable as well potentially, that every term in your expression has in common. So whenever we're talking about greatest common factors, we are looking for one of two things, or both things. We are looking for common factors and common variables. Of course, a factor being a number that is, can be multiplied to turn into something, or it's divisible by. That's probably the way we should think about it. A factor is a number that something can be divided by. So whenever we look at our first example problem here, now this isn't a polynomial, I know, it's a binomial, but it still works. 5x squared plus 15x. Do these have any common factors, or common numbers, or common variables? Well, let's look at common factors first. Our numbers here are 5 and 15. Is there any number that both 5 and 15 can be divided by? Absolutely there is. Both of these numbers are divisible by 5. So I want to write that down. Next, I want to talk about common variables. Do either of these terms have common variables? They do. Both of these terms have x's. Now, they're not the same x's. One is x squared and the other is x. They don't have the same variable configuration. However, when we're talking about common terms, not like terms, but common terms, all we're looking for is that all of these have the same one, meaning all of them have an x, or maybe all of them have a y. What we want to determine is how many does each one have at bare minimum. A better way to say it probably would be each term has at least this many x's. In this case, since we have one term with two x's and another term with just one x, we can say both terms have at least one x. So we have one x in common. So we're going to write that with the 5 here. So 5x is the common term amongst this binomial. So we want to go ahead and factor it out. We want to try to take it out of that binomial. Now, whenever I say the word take it out, I want to be clear that factoring out or taking out common terms means we are going to divide that out. We're not subtracting like it kind of sounds like, we're dividing. So what will happen is we want to take a look at this binomial and say we want to take out 5 and we want to take out x. Well, just like most other operations with variables and whole numbers, we're going to be doing them separately. Let's ask ourselves, if we take 5 and divide out 5, 5 divided by 5, what is it? Well, it's just 1, right? Now we know we don't always have to write 1 because, invisible 1 coefficients, but I'm going to for this purpose. Next up, we have x squared, and we have 1x. What happens if we divide x squared by x? Yeah, we just get 1 left over. It's kind of like subtraction when we're talking about variables and exponents, right? It's not subtraction at all with the whole numbers, but honestly it kind of is subtraction with the variables. We have 2 and we're taking away 1. Now when we look at our second term, we're going to do the same thing. We want to take a 5 out of 15. Again, remember it's division and not subtraction. It's really easy to say 10 is what would be left over, but we want to divide. So 15 divided by 5, well that's 3. And then we want to see what happens when you take 1x out of 1x. nothing's left there, right? It's all gone. So we don't really need this one. I'm going to go ahead and erase it just because that's what we like to do mathematically. And we notice that we end up with 5x being our common factor written on the outside of the binomial, and x plus 3 being what is left on the inside of the binomial, what we weren't able to take 5x out of. And that's our answer. Let's take a look at this second problem. We have a polynomial here, so 3 terms, 6x to the 4th minus 18x to the 3rd plus 42, and I meant to write x squared with that, my bad. What do they have in common? What number do they have in common? Now you may be thinking a couple of things here. You might be thinking, well, those are all even numbers. They have 2 in common. Or all of those numbers are divisible by 3. They have 3 in common. Or you could be thinking, all those numbers have 6 in common. So which one is the number that we take out? Well, there's a really important term here, greatest common factor, right? We don't want to use 2 or 3 because those aren't the greatest numbers. Those aren't the largest numbers. So our greatest common factor in terms of our numbers here is 6. Now let's look at our variables. What is our common factor among our variables? We have x to the 4th, x to the 3rd, and x squared. So we would say each of those terms have at least how many x's? 2. Every one of these has at least 2 x's. So 6x squared is our greatest common factor. Now we want to go ahead and factor that out or divide it out of each of our terms. So let's see what happens here. 6x to the 4th. Okay, we take 6 out of 6, we divide 6 by 6, we just get 1. Cool. X to the 4th, and we want to take out x squared. So we want to take 2 x's away from these 4 x's. How many x's are left? Yeah, 2. X squared. Let's take a look at our next step. We have a negative 18. Don't forget, keep that sign with it. Negative 18 divided by 6. That's negative 3. And then we have 3 x's, and we want to take 2 away. 1 x left. Finally, let's take a look at this. We have a positive 42. We want to factor out of 6 or divide out of 6. 42 divided by 6 gets us 7. And then we have x squared, and we want to take out x squared. Anytime you're taking out the exact same variable configuration as what it has, there's not going to be anything left over. So ultimately, we have our greatest common factor written off to the side, 6x squared. And the binomial left, after you factored it out, x squared minus 3x plus 7. And now we've successfully factored both this binomial and this polynomial using the greatest common factor method. The greatest common factor method is often our starting point anytime we have a polynomial we want to factor. You always want to ask yourself, can I factor it with a greatest common factor? It's not always going to be the ending point of a problem. Sometimes you're going to take out your greatest common factor and realize what you have left can still be factored using another one of our methods. We'll talk about those other methods in another video. But again, this is always your starting point, every time. If you have any questions about this, feel free to drop them below. Otherwise, thanks for watching, guys, and I'll see you next time.